Hey guys, the objective of this video is to do an advanced example, and it's of the frame element. You'll see why in a second. So we essentially have this propped cantilever, except the roller is on a support which is at an angle. The rise and the run is 3 on 4. So this is a bit of a different problem we've seen in the past. Normally it's flat, and the fact that it's on an angle is going to change the problem significantly. It's just a square section, 100 by 100. The E is 200,000 MPa. So as always, we're first going to find we're going to put down the location vector and label our degrees of freedom. So you'll see where it's different now. I'm just going to call the location vector from there to there. The length of this is 10 meters. Now, when you label your degrees of freedom, the global degrees of freedom are always in reference to your nodes. So what you're used to seeing is that, and that, and it might not be obvious why we're doing the frame element just now. You'll see why now. Because if this was flat, you would just do the beam element because you don't have any axial loading. But when you label this node here, the degrees of freedom, it looks like this. So that's actually meant to be parallel to the surface. So this is parallel to that surface. And the rotation. Okay, so this is why this is an advanced problem. This is kind of strange what's going on here. We're going to talk about this in a second and how it works out. You'll see that as we go through the problem. But just for now, I want you to realize that when you draw your degrees of freedom, they're always in the global degrees of freedom. So this is the global axis, as we always do. The global degrees of freedom are always in reference to the node. So the node parallel is there. The node vertical is there. Okay. The local coordinates are always in terms of the actual member. So if we had this member here, the local coordinates would be right and straight up. Okay, so we're doing global coordinates though, as we always do. Now we're going to label the global coordinates as we always do.